Lesson 7.6, finding general solutions using separation of variables. Separable equations. What are separable equations? Separable equations are of the form dy dx depends on both x and y, which can be separated to the form y dy equals x dx. And then after we do y dy equals x dx, we integrate them and we solve to find these general solutions. Okay, that's it. Let's do it. Example. So we got dy dx plus 2x y squared equals 0. And let's find the general solutions to this differential equation. So, it has a lot of algebra involved. It has, but here we go. We want to put this, write this in this form. Okay, so let's have the y dy on one side and then have the x dx on the other side. Anybody, let's see. What would be step one of getting it to this form? Anybody, any ideas? Move the whole thing over. No, you couldn't do it right now. Move the whole thing over that way. Let's do that. Let's move this over the other way. The other side, to the other side. Okay, now we should do what? Maybe? Yes? What you just said. What did you just say? Yeah. Huh?
Move the dx over?
Yeah, let's move the dx over. Okay. All right, let's go step by step, no? Now what should we do? Divided by y squared. Yes? So this cancels out. So we got dy over y squared equal negative 2x dx. So dy over y squared equals negative 6 dx. Okay, now what should we do? Integrate, no? Integrate. Yeah. So the way we integrate y squared, you know that has to go to the top. This is not ln. So we can let's this has to go to, let's do it like this. Y to the negative 2 power and then apply the power property. So move it up to the top. So 1 over y squared is y minus negative 2 dy equals, you can factor out the negative 2, and then we can just, whatever, no? It's all right. So what's the integral of this y negative 2? It's just the power property, no? What is it? If you have integrate x, what is that? X squared over 2, no? Yes. So what do we do here? We're going to add 1 to it. So what is that? What's negative 2 plus 1? So it's going to go back to the bottom, and then you're going to have over negative 1. Look. So we integrate. Let me just go. So y to the negative 2. So we do plus 1. And so that's going to be y to the negative 1. Negative 1 at the bottom. So it is negative 1 over y. Yeah? Yeah? So it's going to be negative 1 over y. Okay? Equals what? What's the integral of this? X squared over what?
2.
And then they're going to cancel out, so it'll be negative what? Negative x squared, yes?
Oh, yeah.
And then what? Let's not forget for this what?
Let's see.
plus c. So we gotta get the y by itself. How do I get the y by itself? Look, this is algebra. This is the thing about it. It's just not. Look, what I'm gonna do is I'm gonna multiply everything by y negative. No, just by y. Yeah, just multiply by y. Both of these sides by y. So then I can have the y be on top, not at the bottom. All right, so they're gonna cancel out. So then I have what? Negative 1 equal, let me put this in the front, y in parentheses, negative x squared plus c. And now how do I get the y by itself? How do I get the y by itself? Divided both sides by what? It's a negative divided by. Look. This is just a constant. So whatever, I'm going to times both the top and the bottom by negative 1. That's what that lady did yesterday or the other day when she did that one problem. It doesn't do anything. Negative 1 divided by negative 1 is 1. So then this makes it positive 1 over positive x squared. And negative 1 times c, who cares? It's just a constant. Plus c or put a minus c, but it doesn't matter. It's just a constant. So this is the answer, should be the answer right there. Yeah. Yeah, this is getting, it's just algebra intensive. That's what's the problem here. So there. Same goes, answer, no? Moving on. Next. All right, let's go. When there's only one variable in that it equals to, that dy dx equal to one variable, you see that there's only an x here. You don't see y's. That makes it much easier, much easier to work with. So, what do we do? Step 1. Yes, move the dx over. So then let's do that already. Dx here. Dx here cancels, then dy equal x minus 2 to the third dx. Then what do we do? Integrate. So this is what? Y is equal to. So going back to chapter 6, if again, I hope you remember chapter 6. How do you integrate something like this? Good thing, again, that this is linear. Y equals x minus 2. This is a linear, so it's good that we have a linear thing. So we can use u substitution. If we let u equal what? That linear thing. X minus 2. Yes. If we let u equal x minus 2, what's du? 1. Thank you. What else? Dx. Yes. Dx. Yes. Okay. So now let's plug it in. So y is going to equal to what? U what? To the third, no? And then what? Dx or du, isn't it? Yes. Look, yeah. Look, x minus 2 is x minus 2, which is u cubed, dx is du. Everything gotta be in the same. All right, good. Well, yeah, good. And so let's integrate that. What's the integral of that? Come on. U to the fourth over 4. Then what? And this one was easy. So y equals what? Just plug back in what we had. Y equals what? That's too, yeah, it's too easy. So it's going to be what? Plug in u. U is what? X minus 2 to a 4. You can put a 1/4 plus c. I don't know. This one, whenever you have a linear part in here, you're lucky. It's easy. It should be very easy. If it's not linear, then it gets more complicated. Whatever. It's too easy. I don't even know what. All right, moving on. All right, let's go number 2. All right, so you guys should know already the first step in this particular one again. Move the dx over. So this is dy equal 2 over x squared plus 1 dx. Oh, did I already put the integral here? I did. All right, I'm already doing the integral for both. Integral of dy, 2. So y, so this is going to be y equals. What's the integral of that? Either you know it or you don't. What's the integral of that? Tangent inverse is correct. So it's going to be what? 2 what? Tan inverse of x plus what? Plus c. And we're reviewing for the AP test already, and so there's that. With this, we're reviewing as well 2 tangent inverse of x plus c. Yep. All right, moving on, number 3. And it's pretty much you learn by doing it over and over, and then you just kind of get the pattern of it, and that's all. Sometimes it's not too much how I teach it or what I do. It's just getting familiar with it. What's step 1, 2, come late? Yeah, yeah, that's it. Minus 2xy. Then what should we do? I don't know, they're interchangeable. What should be the next step? Wait. Multiply both sides by dx. dy equal, I guess I'm just doing too many steps here. We could just do all of it at once. But anyways, what do we do next? No. Divided by what? Y. Now we take the integral. So what's the integral on the left? What's the integral on the left? ln absolute value of y. What's the integral on the right? What else? Okay, here's what I just said last time, that we're gonna work with this. This is okay. Let's see, what's the next step? Put it in exponential form. So what is the base of ln? So it's gonna be e to this power equals this. And I said that I was gonna give you an explanation on why this is true. That we're gonna drop off the absolutes. I don't exactly have it. I didn't go home and look for it. But anyways, you drop these absolutes when you solve them. So it's gonna be e to the negative x squared plus c. All right. Look, let's go to this. I'm gonna do a little review of pre-calc again. Here's a little review of pre-calc. If I have let's not have e. Let's have 2 to the power of 3 plus 2. Well. Okay. Well, what is 2 to the power of 3 plus 2? Well, would you agree that it is 2 to the 5th? Yes or no? Yes. Now, would you agree that this also is true? Let me go here. That 2 to the 3rd times 2 to the 2nd is 2 to the 5th. Would you agree on that? Yeah. All right. If you agree on this being true, then if you understand this, what I'm saying, then you should agree on what I'm going to do here. So y is going to equal to e to the negative x squared times e to the c. Yes? And now, what's e to some constant? Well, e to some constant, to whatever the constant is going to say, I'm going to say the constant is 5. What is this? It's also a what? It's also a constant, no? So then this becomes what? A constant. This whole thing becomes a constant. So then I'm just going to say e to the c is a constant. So then e to the negative x squared, that is the answer to this. So that's to this thing is y equals c times e to the negative x squared. Ooh, I'm teaching it wrong. You don't remember that I said I was gonna go home and I was gonna go look to drop it. Is that what I said? To drop the absolutes? What do you think so? Absolute value, and I had dropped it in let me go back to it. I dropped it. See here where I'm saying and then it's absolute, and I dropped it in what I did, and I guess I'm wrong. You're not supposed to drop it. Let me go back. So let me go back. Go forward. Forward. I'll erase. So you're not supposed to. So we went here. Hold on. Where are we at? So we went here. No, we're here. What's the only? Is this the final answer? No, this is the final answer. And what did I have as an answer though? Hold on.
You just had the bottom left, but top left.
Yeah. I had it all, but hold on. I had it. Why is this at the bottom though?
Because it's negative x squared.
Oh, it was negative x squared, so you bring it to the bottom.
Yeah.
Okay. So okay. All right. We'll do some problems when we get to the to these AP test problems, and we'll just do whatever they want us to do. So it's absolute. If it's absolute, you're supposed to keep the absolute, and then therefore you got to put a plus or minus. So that's it. Let's go. Move on. Next, number 4. we just give them what they want. So, can we do like everything at once? Yes or no? Maybe? Or no? We know that we got to move the dx over. Yes or no? So this is going to be dy. And then what else do we do? To get this divided by y both sides, no? Is that okay? So it's going to be dy over y. And then what did I say? After a while, this thing just becomes a bit repetitive again, no? So you got this dy over y, and you got sine x dx, and you integrate. And so dy over y is what? Ln absolute value of y. And that's equal to the integral of sine x dx is what? Integral of sine x dx is what? Negative cosine x plus c. And then you do this. This is the way I'm doing it now. E to this whole thing. E to this whole thing is equal to this. So absolute value of y is equal to e to the negative cosine x plus c. And I guess let's keep the absolutes on it. And so this is going to be absolute value of y equals. Then you're going to go e to the c times e to the negative cosine x. Yeah. And so then we do absolute value of y plus or minus c over e to the cosine x, because you got to bring it to the bottom. Easy, no? We're all right. Man, what the heck? What? Look.
Goes away anyways.
Huh?
Goes away anyways. Like how you add it over.
Why? How?
Because if you're just taking away the plus or minus, then you could just drop that absolute value.
Let's go to number 4. Just continue. You know why? You know why though? You know why? Because this constant could be positive or negative. So whatever that constant is, if it's negative, then it will change the whole thing to be negative. If it's positive, it will just keep it positive. It depends also on the constant, whatever that constant is. All right. What do we do here? Dx over? Yes. So this is going to be dy. Look, the dx is going to go over here. Can we do everything at once and you know that everything, the dy's, everything y has to go left and everything x has to go the other way? Can I already divide by 1 plus x here? Divide by 1 plus x here? Let's do that. Let's do it faster. So this is going to cancel out, and I got to divide by y here. I got to divide by y here. Okay? So this is going to cancel out. So I'm going to have dy over y equals, and it cancels out, 4 over 1 plus x dx. Is that okay? Everybody? Yes? Yes? Uh-huh. Okay. So this is going to be what? ln absolute value of y. What is this going to be? Look, what did I say about something being linear? This 1 plus x, x plus 1, anything linear, you know, so it's going to be what? What's 4 over x? How do you integrate 4 over x? Ln, and there's absolute value of this linear thing. Whenever it's linear, it's fine. So we're going to go for what? Ln absolute value of x plus 1 or 1 over and then plus c. Put it in what? Oh, well. Look. Properties of logs. You guys remember properties of logs that you could bring this to the top of this thing? Did I do why are two absolutes here? X plus 1, hold on. X plus 1. ln x plus 1 and then plus c? Yeah. So you guys remember that property of log, no? To bring it to the top here? You guys look. If you have something like this, you have 3 log base, whatever the base is, I don't know, base 2 of x or something like that. The property of log is that you can bring this 3 to the top. So this is log base 2 of x cubed. So that's what this property I'm going to use to bring this 4 up to the top. So then this is going to be ln, man, this absolute is just, so then ln x plus 1 to the 4th plus c. Ln y, ln. So we're going to just take the e of everything. Is this allowed? Is it or is it not allowed? Look, let's go. Let's see. Better get rid of this so I can write here. All right, look. What we're gonna do is bring these ln's next on the same side. So I'm gonna bring this over this way. Let's go. So this is gonna be ln y minus ln x plus 1 to the 4th is equal to c. What's another property of logs? See, man, if this is another property of logs. You guys remember property of logs? What is this when you have what? Ln of x minus ln of y. How do you rewrite ln of x minus ln of y? How do you rewrite ln of x minus ln of y? You guys did take pre-calculus, no? Okay, so when you have 2 natural logs or 2 logs, you can go from 2 logs minus corresponds to divide. So ln x minus ln y, it is ln x over y. Ln x over y. So I'm going to use that property here. And why am I going to use that property? I don't know. So let's do this property here. So it's going to be what? Ln y. But why am I doing this though? Ln y over, no, hold on. Oh, I know why I'm doing this. So this is going to be what? Tell me. If we're going to do that property, put it here, what are we going to do here?
ln y over x plus 1
Is equal to what? And then what can we do? Put it in. Yeah. So this, I'm all over the place, but then we're going to go what? E to the c is equal to this, no? So it's equal to this quantity here. So y over x plus 1 to the 4th is equal to e to the c. And e to the c is what? It's just a constant, no? So maybe I'm doing too much. I'm going all over the place. Maybe we could have done this much faster. But anyways, x plus 1 to the 4th is equal to c. Now how do I get the y by itself? How do we get the y by itself? Oh, yeah. How do we multiply by x plus 1 to the 4th? So by this, so y is equal to c times x plus 1 to the 4th. That's the answer right there. So yes, I see that if you have to really have good remember what the logs unit was about when you did that logs. absolutes again. Dude, I don't know who am I gonna talk to? Like, look, you see, why is this now? Why does this have the absolutes and not this one? You see that how? Let me see. Hold on. Let me see. It's not done. It's still not done.
I guess just because they have the X in it.
Anyways, we're done. We're done with this.